Let me demonstrate how to use backward substitution to solve this two system. This is a system of linear equation, one system, three variables. So the first system is x minus 2y plus z equals to 10. The second equation is 2y minus z equals to 2. The last equation is 3z equals to 12. The first step you take care system is you always number each equation. Equation 1, equation 2, and equation 3. This time I would like to use backward substitution because the third equation is 3z equals to 12 is one unknown in one equation, so this can be solved immediately. So we have 3z equals to 12. When you divide both sides by 12, you have z equals to 4. So once you solve one of the variables, the rest is very easy. So since we have z equals to 4, I will plug this in to equation 2. So equation 2 was 2y minus z equals to 2. Since z is equals to 4, and then you put a 4 right here, and then you have 2y equals to 2 plus 4 equals to 6, and then divide both sides by 2, y is equals to 3. So now we have x and y. We have z and y. How about x? So now we have z and y, so why don't we plug in the y and the z to the first equation? So the first equation is x minus 2y, so which is 2 times 3, plus 3z, 3 times 4, equals to 10. So this is a x minus 6 plus 12 equals to 10. 12 minus 6 is equals to 6, and then you have a x plus 6 equals to 10, and then x is equals to 4. So this system has one solution, so one solution, and then the solution is written as x comma y comma z. X is equals to 4, y is equals to 3, and z is equals to 4. Okay, what does that mean? So when you have a system of linear equations, so let's say you have an x and y only, so x and y both variable is raised to the first degree, that means you have a line. So if you have a system of equation, two variable, x and y, that means you have two lines. So the two lines, and then you have one solution. That means those two lines, they meet at one point, and that point is your solution. How about three variables? So for three variables, x, y, and z, they are all raised to a first degree. So in this case, you are no longer having one line. So you have a plane, a three-dimensional plane in this situation. So what does that mean? How do you picture that? So let's say you are holding up a piece of paper, the paper that you used to print your essay. So let's say you are holding up a paper in the air. So this paper is two-dimensional, but you hold it up in the air. So that your air means in your room, in a three-dimensional space. So let's say in your room, and then you have three equations in system. So that means you are holding up three papers. I know you cannot really do it physically. Just picture this in your mind. So the first equation, equation number 1, represents a piece of paper that you are holding up in the air. And then equation number 2 is another piece of paper. Equation number 3 is another piece of paper. So these three pieces of paper, they meet at one point. They are intersecting each other, and then they meet at one point. So which is, you get one solution. So since they meet at one point in a three-dimensional space, so the location of that point is x equals to 4, y equals to 3, and z is equals to 4. And then there is another situation is they meet at a line. So that is also one solution. All right, so let's take a look at the blue system. So the blue system, I have 4x plus 3z equals to 10, 2y minus z equals to negative 6, and then half z is equals to 4 using backward substitution. I would like to take care of the last equation. So the last equation is 1/2 z equals to 4. You multiply both sides by 2, z is equals to 8. So when I do system of equations, once you get one of the variable, the system will become much easier. So let's plug this into equation 2. So equation 2, now we have 2y minus z equals to negative 6. All right, so what is z? Z is 8. 2y minus 8 equals to negative 6. and then you add a on both sides, so you have 2y equals to negative 6 plus a, that is equals to 2. Divide both sides by 2, you have y equals to 1. So now you have z and y. Plug in the z to the first equation. So the first equation is 4x plus 3 times z, which is 8 now, equals to 10. 4x plus 24 is equals to 10. 4x is equals to 10 minus 24. And then you have 4x equals to negative 14. And then divide both sides by 4. You have x equals to negative 14 divided by 4. You have negative 7 over 2. So now there is one solution. X comma y comma z. And then that solution is x is equals to negative 7 over 2. Y is equals to 1 and z is equals to 8. So when you do homework online, be aware that they might not accept decimals. So sometimes you have a 7 over 3. You do not want to approximate that. You want to report the exact value, which is fraction. Okay, what does this mean again? So that means I have 3 planes. Number 1, number 2, number 3. They live in a 3-dimensional space. They meet each other at one point or one line, and the location of that point or that line is x equals to negative 7 over 2, y is equals to 1, z is equals to 8. Again, this x, y, z coordinate is like the location, okay, the location of a point, and then here is the exact location. And then we say that these 3 planes, they meet at this location. All right, so that is the end of this video. I have more systems to solve in the upcoming videos. I will meet you there.